Hi everyone, I'm Yuchen Zhang from IELTS at the University of Essex. Today, I'm going to present our recent work for work package 4 of the project ELOQUENCE, context-aware multilingual and multimodal speech LLMs. Context information has been proven effective for monolingual ASR tasks, and the researchers have always put context information along with the speech to improve the performance. However, two questions still remain unexplored. The first one is how multilingual ASR benefits from different type of context information. The second one is how to better align context information and the speech. To address these two questions, we propose a context-aware multilingual multimodal speech LLMs. So we have three different part of inputs. The first, of course, is the speech input. It will go through a speech encoder and then get the speech embedding. The speech embedding then will be further processed by the speech connector. And like the speech input, we will also have the context information, which will be processed by the embedding layer of the LLM. And then the most crucial part for our approach is that we will apply a contrastive loss on the speech embedding and the context embedding. And then with a task specific prompt, we will get a context-aware multilingual multimodal ASR. So here's a little background information about the contrastive learning. Here we use contrastive learning to implement our cross-modal aligner. What is a contrastive learning? So the basic goal for contrastive learning is to learn a feature space where similar samples, or we can call the positive pairs, are closer, and the dissimilar samples, which we call negative pairs, are further apart. So how this works? We will have an anchor, a reference image. So in the figure in the left, we can say the anchor should be the dog. Then the positive pair should be another dog. It could be another breed of dog, or it could be the different angle of the view of the same dog. And in a contrast, the negative pair should be a different type of animals. It could be an elephant, or it could be a cat. So the goal of this contrastive learning is to learn a feature space that the pair of dogs, the pair of dogs that get similar and get closer. However, the pairs consist of dogs and the other animals such as dogs and elephants, dogs and cats. Their feature space will be pushed further. So here's an example in our task. In the ASR task, we have context such as histories. You can see from this figure, there are context column and there's a labels column. So we can see the context here is basically the previous ground truth transcription of the current speech. So we can use this as the context. So in our setting, the anchor should be the current speech that need to be transcribed, and the positive should be the context info of the current speech, and the negative sample should be the context info of the other speech. And the input of our system should be the context info followed by our task-specific prompt, given the above context information, transcribe the following speech, and followed by the speech embeddings. And after getting this input, the LLM will generate the transcriptions. Here is the details of the context we look into in our research. We are looking into two types of different contexts. The first one is the dialogue history. So we have defined previous KDH turns of the dialogue as the dialogue history, and the prompt of this context should be the previous turns of the speech is. And also, we also investigated another type of context, the biasing words. Biasing words consist of two different types of words. The first type of words is hot words. The hot words are randomly sampled word-level n-gram phrases from the transcription of the current uterus to represent the keywords or the key meaning of the current uterus. To avoid the hot words apply too strong signal, we will also include the distractor terms in the biasing words. So like the name implies, the the distractor terms are randomly selected words from a rare-word lexicon built from the transcription of the training set that are not in the current utterance. So the prompt for the biasing words should be the speech might contain following words, and that should be a word list contains the whole words and the distracted terms. So formally, the model input should be speech, followed by the user prompt, and the assistant, and followed by the transcription. So the prompt should be transcribe the speech to test the following context information might help, and then provide the context. So the context in our experiment should be either the dialect history alone, or biasing words alone, or combine the biasing words and the dialect history together. We conduct our experiment on this MLC SLM dataset. It's a multilingual dataset containing 11 different languages and also contain 5 different English dialect variations. So in total, it had 1,500 training hours, 32 hours of validation sets, and 32 hours of testing hours. Here is the results of our context-aware multilingual speech ASR. You can see from the results, the no context means we only feed the model with a speech, and then apparently it gets the worst results. And as soon as we add any type of the context, we can find there's a huge improvement of the ASR performance. We can see no matter we add history or biasing words or combine them together, we will have nearly 5% of the improvement on the average word error rate or character error rate. This proves that context information consistently improves this performance for multilingual ASR. And then when we try to apply contrastive learning for different type of contexts, we find interesting results. So our hypothesis should be, since combining two type of context gives us the best performance within the 3 different types. So we're assuming that when we apply the all context to contrastive learning, it will also give us the optimal results. But surprisingly, it's not. The best result is generated by the history with contrastive learning, and then followed by the all context with contrastive learning. And the biasing words with contrastive learning give us the relatively worse results in the context and the contrastive learning settings. So the possible explanation is that because in the biasing words, we deliberately add some distracted terms, and when we using contrastive learning, the model will force the embedding of the speech and the context to get closer, but the context will contain a distracted term, so which is a noisy embeddings. So this might be the reason that history alone with contrastive give us the best results. So here are the main takeaways for our recent work. Listen in context. The contextual input consistently improves the recognition quality. Contrastive alignment provides additional gains when applied to different context types. And third, for heterogeneous context, contrastive learning is not always optimal. Thank you for listening. If you want more details, you can always check our paper. Thank you.